This is the 9th video in a series in which I'm restoring this Creed 7B teleprinter. So far I've completely stripped the machine, I've rebuilt several of the main modules, I've taken out the wiring loom, repainted the base and several other of the parts, and in this video I'm going to start reassembling the mechanics. So I'll be doing it in the reverse order that I took it apart, and as I come to each module I'll either rebuild that module, or if it's one I've already rebuilt and tested, I'll just reinstall it onto the base. So the first part I'm going to fit is this. This is the cross drive shaft for the tape feed. Quite a clever mechanism. There are two pillars that the tapes actually rest on. There's one this side, one this side, and this mechanism is to drive the tapes. But it's also to automatically reverse the direction of the tape travel when the tape gets to the end. We'll have a look at that later when I refit the tape drive pillars, but for now I just need to install this because it sits underneath everything else, and once I start fitting the main modules I won't be able to get this in. So it's just held in with 4 screws. Okay, so that's the shaft fitted. It spins nice and freely, and it clicks into the 2 positions it runs in correctly. So that doesn't need adjusting as far as I can tell at the moment. So the adjustment would be to make sure that the 2 cogs on the end engage properly with the crown wheels on the 2 drive pillars. I did check it earlier and it seems fine, so I'm hoping I won't need to do anything to adjust that. I can get to this once it's assembled, but hopefully it won't need adjusting. Okay, so the 3 main parts I've got rebuilt so far, I'll try fitting. I don't know exactly what order these are best fitted in, but I'll put them all in loosely to start with and then see if I need to move or adjust anything later. So that's where the first one goes. Okay, well, that took some jiggling about, but it seems to be in the correct place. It will need to be aligned before I bolt it down, but it does all seem to be sitting where I would expect it to. Okay, so the next piece to go in is the receiver unit, or receiver control unit. So this is really the unit that is responsible for decoding the incoming signals. So it's effectively the same as a receiver module in a serial system. So again, I'll just put a bit of lubricant on the mating surfaces before I slot it into place. Okay, that seems to have gone into where it's supposed to. What I'm doing here is there are some adjuster stop pegs. I don't know if you can see them on camera. There's a few of these dotted around, and they sit between each of the major modules, and I'm assuming that these were adjusted on a jig when the unit was being manufactured, so I haven't moved those. So in theory, by bringing them all together, bear in mind that the main unit is on pins on the base, which I haven't moved. So this unit must be in the right place, and because all the other units will be pushed up to these adjusting pegs, then if I bring it all together and push all the units against these pegs and then tighten down the mounting screws, then in theory it should all be pretty much aligned and I shouldn't have to move it much. But what I'll do is I'll get them lightly bolted down, and then I'll see if everything works the way it should do. So I'll do that off camera. It's a bit fiddly and time consuming, so I'll just run through all this, make sure it's working as it should, and then get back on camera and we can bolt all the units down. Okay, so that's the major assemblies refitted. I've aligned them and adjusted them up to the point where I can't really go much further without the motor fitted and the machine running. The critical adjustments I've got as close as I can. One of the main ones is the throw of this release arm. If it's too tight, then the peak torque required during a cycle can be high enough to strip this gear, so it's quite a critical adjustment. And if it's not tight enough, then some of the bits or all of the bits may not clear on each cycle. Now, one thing I just want to quickly demonstrate here is I mentioned in a previous video that the timing of this thing doesn't seem to be quite what you'd expect until you sort of go into it in detail to see exactly what it's doing through a full cycle. I just wanted to demonstrate that here. It's going to be fairly difficult to see on camera because some of the parts are fairly small. But the way that the character is selected is by the incoming serial data being translated into a series of positions for these 5 levers, this being a 5-bit machine. Now, in the default state, this arm, which is attached to the solenoid, sits in this position. If I drive it through to the end of the cycle, just so we can get, you can see that it sits in this idle mode. And if you're familiar with serial communications, you know that in general you need to have one or more start bits in the communication protocol, and that's really where the requirement for those start bits came from. What this start bit does is it takes the mechanism out of this default hold position. So at the moment this gear just spins on a ratchet. If we start the machine running by supplying it with a start bit, then effectively what happens is the solenoid will change state and then it will engage this gear. So you can see it's now starting to move. So the start bit that's been provided to the solenoid takes it out of its idle mode. The following bits, the data bits, now go through, and depending on the state of the solenoid will set or leave these little levers. And if the solenoid is in the position it is now, this pin, when this lever moves across, will be left in the current state. But if the solenoid is in its other state, the mark state, then the pin will be pushed across and it will move these little fingers across, as it's done there. So you can see that the first one we had a 0, the second one we have a 1, so it moves it across, and it will repeat that, or it will go through the remaining bits and it will set those fingers accordingly depending on the state of the solenoid. So in other words, it's taking this serial input and it's saving it as a binary value on these fingers. So I'll go through and assume the rest are zeros. And this is where the timing seems to be wrong. Bear in mind, this lever is the hammer operator for actually printing the character onto the paper. So when you see this move, that's when it's actually printing. So it's set all the bits. So you can see now it's printing, but it's not printing this character. We haven't actually put this character into the selector drum yet. The selector drum has the previous character stored, so that's what it's now printing. What it's now going to do is going to replace the character that it's selected in the previous cycle with the one that we've just set. So as we continue to rotate the gear, you'll see that these fingers now start to raise. They're coming up, and it's going to set or select whichever of these fingers it needs for the particular character that it wants to select based on the code it was sent. So what it's doing here is it's replacing the selected finger with the new one, and then it carries on, resets the fingers, and it's now going through the next cycle. But because this has been set with the character that we want to print, it hasn't printed it yet, it's just stored it in here. It will print it towards the end of the cycle. So it's now receiving the next data byte. As it gets to the end, we'll see it's now printing the character that we received previously. And then it will go through and it will replace the value in the selector drum with the one it's just received, and so it continues. So the timing seems to be out, but it's mainly done like that because it's a high-speed a mechanical machine, so it needs to allow time for certain things to happen. And amongst those is the need for this to drive round to the correct position after these have been set. So this selects the required character, but it doesn't print it. It requires the motor to carry on spinning through this gear to select the actual character we've selected. So in other words, it can't do these two things at the same time. So it selects the required character, or the requested character, at the end of a cycle, and then through the next character cycle it will position the print head in the required position, and then just before the next cycle starts it will actually print the character onto the paper. So that's why it's done like this. It's just because it takes time for certain things to happen, so it can't do some of them instantly. There are, as I said before, there are clever things in the machine in the way it's configured to save on extra mechanisms, and one of those, you probably can't see it, but down here there is a pull and ratchet system that operates the shaft that drives the tape. So each cycle it clicks that round one stop to advance the tape. So what I'm going to do now is fit the tape support drives, see how they fit onto the machine and how they're driven by part of this mechanism. So I'll just reposition the machine and get them fitted. Okay, so there are two of them. Quite clever. They've got this auto reversing mechanism built into them. Obviously I've cleaned these and freed them up and lubricated them. There were or one of them at least wouldn't rotate at all, so it was just corrosion and mud that had built up. So they fit into these positions, and the crown wheel meshes with the gear on the end of this shaft, but only on one end at any one time. The tape, there's a little pawl up at the top that detects the presence of the tape, and if the tape runs out or gets to the end, the tape is still attached to the drum, but it causes this shaft at the bottom to drop, and then through this tapered portion on the end of the shaft it causes the shaft to change position, so it will be either in a position where it's engaged with this crown wheel, or it can move across and it will engage the other end of the shaft with the drive on the opposite end of the machine. So in other words, this shaft just goes back and forth in response to the tape getting to the end, and then it reverses direction and winds the tape back the other way. Okay, so I'll get these two fitted. Okay, so that's the first one fitted. The second one is very similar, it's just a mirror image of the first one, and of course that goes at this end. Okay, so they're both in place. I'll rotate the machine through a couple of cycles and you'll see these tape drives advance. It won't work as it's supposed to, and it'll keep swapping direction because there's no tape on the reels, so both ends think it's at the end of the tape, but you will see them turning. So as you can see, this tape is in its take-up mode and the other tape is in the freewheeling mode. And then what happens is at the end of the tape, the shaft will move across automatically, and then it will do the reverse. This will be the take-up and this will go into freewheel mode. So very clever design, very efficient in terms of the use of certain moving parts to do more than one job. Starting to look like a teleprinter again. So I have fitted various other parts to prevent the video getting too long. I'll go over the other functions in more detail as I start fitting the remaining parts. This thing does a lot more than I've described so far. It has sort of character shift functions and that sort of thing. But I'll go over those as each part is fitted. So in the next video I'll refit the solenoids, and I'll refit the drive motor and the drive motor filter. And then once I get to that point, I will probably try and running up the motor just to make sure everything spins freely and as it should do, before I start trying to work on the keyboard and the carriage.